So welcome back to Statistic 2 Continuous Random Variable. In this video, we'll be talking about the mean, the variance, the median, and the mode of a continuous random, of a probability density function. So I just say here you have. So first, we'll talk about the mean. So let's just say here you have a graph. And the graph looks something like this. P stands for probabilities. So now you need to find the mean. So for a discrete random variable, we have learned that we can find the mean by timing all the axes with its frequency or timing all the axes with its probabilities. Right, so timing all the axes with its probabilities, that's how we find the mean in the discrete random variable. But now, to find the mean in a continuous random variable, we get all the ways to do. So we have known that the probabilities can be found using f of x. So now when we time it with x, so x is here, and we set the range. Let's just say the range is from 0 to a. 0. So we set the range, and so this is the formula for the mean, in which we take the x, time it with its probabilities, the dx, and then setting the range from 0 to a. So this will give us the mean. So this is the formula for the mean. Right. Now the variance. Let's just say we also use this graph. Right. So just use this graph. So we have the mean. So this is the mean, right? X times f of x dx over a. So for the variance, we need to get not only the mean, but we also need to get the mean of the x squared. So the sum of the x squared. So yeah, so this is, let me just delete this. So we need to get sum of the x squared. So the sum of the x squared goes something like this: a0 x squared fx dx. So this is the sum of all x squared, right? And from the formula we have known, so we need to minus this with a0 x. Minus this with the mean and square it. And so minus this with this mean and square it. So we get the sum of all the x squared. So sum of the all of the x squared. So we get the x squared from here, time with all the probabilities, and we can get the mean of the sum mean. Sorry, we can get the mean of all the x squared, minus it with the square of the mean, and we get the variance. So this formula is also taken from the discrete random variable formula, in which it goes such as all x squared times p. This is the sum of x squared times p minus the mean square. So this is quite similar to the way in discrete random variable. Remember, this is the sum of all x squared times its probabilities. Right. So that's how you find the mean and the variance. Now the median. So median is as such. So the median is as such. So we also get a graph, right? let's say we also get a graph. Graph or something like this. This is x. So the median is where there is a 50 of author's values on one side and 50% of all the values on the other side, or 0.5. So this is point M and this is 0 and this is A. So when we integrate the probabilities of f of x dx, so if we look to get the area under 0 to m, so 0 to m, this should be equal to 0.5, because the probabilities from 0 to m is this area, which is equal to 0.5, half of the area from 0 to a. And also similar to if we was from m to a, this area is also equal to 0.5. So thus, all we need to do to solve for m is to replace it into this equation and get m. So m will then be the median of the graph. So, and finally for the mode, let me just delete. So for the mode, in this case it is different because we no longer integrate, but rather we sort of differentiate. So we all know the mode is one where there's the highest probabilities, right? So in this case, mode will be this one, this value. Now we have this graph, and when with mode, in this case we no longer integrate, but rather we differentiate. So let's just say we have f of x, and when we want to find the mode, we need to differentiate it, equating it to 0, and then finding an x that satisfies this condition. Now that x will be the turning point. That x will be m. And because if it's equal to 0, this will be a stationary point. So we know that the probability will be the highest if the differentiation of f of x is equal to 0. We know that the probability is the highest, and for that, m would be the mode. So differentiate f equate to 0, get x, and that would be your mode. So that basically how you can find the mean, the variance, the median, and the mode of a probability density function.